I start? Okay. So hello everybody. We are going to start the tutorial session. So I just want to have a feeling of how many people have installed TensorFlow already? How many people have not installed TensorFlow? Everybody has installed TensorFlow? Okay. Alright, let me just go fast in case there are other people in the other room who have not installed TensorFlow. So basically the procedure is here on the PDF file that you can find on the GitHub. There's a folder tutorial 1 where there is a PDF file, and you just have to basically follow this instruction. I mean, the recommended one, because you could click this link here and you see various options on how you can install TensorFlow, but the one we recommend is to download Python 3 from here, basically. So if you click here, you're gonna go to a link somewhere in Anaconda. Let's see how fast or slow this stuff is. Let's see. Well, it takes forever. Anyhow, so if you go there, you're going to download Python 3 for the version that you have on your system, Windows, I don't know, Ubuntu, Mac OS. And then basically you can create a virtual environment with TensorFlow. You go on Anaconda to open basically a terminal. You click, you just follow these steps on the terminal, like conda create TensorFlow, Python, here is with Python 3.6, source activate TensorFlow or conda activate TensorFlow, pip install. So this package URL here, you can find it here, depending on the version that you have on your operating system. So here there are different kind of links. There's a link for Windows, whether you are using GPUs or CPUs, also for different like Ubuntu or Mac OS. So you take the link that corresponds to the operating system that you have on your laptop, you put it here, and then pip install, ignore install, and then that link, upgrade that link, pip install, upgrade TensorFlow, and pip install Matplotlib. Alright, and then that should install you TensorFlow and Matplotlib. And you can basically on your terminal type Python W, and then it will open you some kind of working space. And then if you click import TensorFlow, if it doesn't make an error, it means you did well the installation of TensorFlow, right? And same thing for Matplotlib. So that was it. This is just for Spider, but most of you guys have done it. So I will leave this, and I also put a program that I basically copy paste from TensorFlow page that you can test to see whether your version of TensorFlow is working. This is just like downloading some data set from the NIST data, and then it divides it into the training set and the test set, like Ron was talking about today. And then here basically you define your neural network, right? And then you have here you flatten, so you have a 28 by 28 image, you flatten it in an array, and then you have an activation layer of 512 spins with the ReLU activation function. I think he mentioned it today, like this flattening and this line, yeah?
So what is the program?
What is what? Sorry, I didn't get it. Alright, okay. And yeah, so you have the activation function. He didn't mention this dropout function, which is basically a way to deal with how do you call this thing? Over-parameterization of your network. And then the last activation function is the softmax. And the optimizer he uses is an Adam optimizer. We could be, he talked today about stochastic gradient descent, but there are different ways in which you can basically optimize the parameters in your neural network. And yeah, and then you check the accuracy. And then when you just run the code, and you're going to see the accuracy on your training set and then your test set. So here the number of epochs is 5. So this is just a test, very fast test for you to check, whether your TensorFlow is working. I'm not going to dwell on this. I'm going to dwell mostly on the tutorials that we are supposed to have for today, which is here. So now you assume everybody has installed TensorFlow, okay? And we are going to deal with, why this? Sorry, it's not this one. Okay, so I come here. Alright, tutorial 2. So you can find it on the GitHub page. So feed file networks in TensorFlow, which is basically what Ron was teaching this morning. So the idea is that we want to have a data set like this. So you have these 2D points with k branches. So what I call branch is, you see you have 3 sets of colors, and this define one branch, another branch, and this is another branch. So what you want to see is that given one point in this plot, you want to be able to predict in which branch it belongs to, right? So it's some sort of classification, right? And you want to do it using a fit-for-all neural network, right? So the input data set is given by this point that has basically an x1 coordinate and then an x2 coordinate, and at the end of the day you want to be able to classify which branch it belongs to, all right? So there is a program in the folder tutorial 2 on the GitHub page called tutorial2 spiral.py, and basically the program starts by generating a random set of these 2D points with k branches. So if k equals to 3, you are going to have this kind of plot, right? And then next, okay, yeah, like it is with your goal is to classify basically the branches, and you will use what the so-called one-hot encoding. So instead of having like k equals to 0, 1, or 2, you are going to have this kind of encoding, and you will need to figure out why it's important in the tutorial. So it's one of the questions. I will not tell you the answer now, right? And so yeah, when you run the code, it generates two plots. The spiral data plot, which is the one I showed before, and then the one with the results. That gives you the results of the training, right? So the tutorial is divided into 2 parts. The first one is where you are going to look at the neural network architecture, understand the fit-for-all neural network architecture, where the hidden neurons are, the activation functions, how one of the things you have to do is to like add an additional hidden layer and see how it affects the accuracy of your training set. And then you will look at different activation functions and different cost functions and play with the learning rate and see how it affects how well you're able to train, right? So the first point is just to run the code, which is quite easy. Okay, if I run it for you, this is basically what you're supposed to see. Wait. What is happening? Wait. Okay, now 1 second. Okay, mamma mia. So, alright, if you have an account like me, you go to TensorFlow, and it takes forever usually. So here I'm loading TensorFlow on Anaconda. And it takes forever. Alright, let's do something. Alright, why is this thing going? It's super slow, this thing. I don't know why. Mamma mia. Alright. Alright, and then I have to go on TensorFlow. Okay, spider. Alright, so I open the code. Okay, and then I should run. Alright, so this is what you're supposed to see. So you have your data set, what I was showing you before, and basically this line is how well your feed-forward network is able to like classify like where this point before, which branch in which, so basically in which branch the point belongs to. So here you see that it does a very bad classification because it divides, basically the data set into three parts. You have these blue parts here, the yellow parts here, and then you have this kind of violet part. But you see that in this blue part, there are data points that are in different branches. So basically the neural network is not doing a good job here. And when you look at the training cost and the training accuracy, so basically you expect to have a cost that is going to 0, right? Here we are using, so the cost function is the cross entropy, right? So it's a measure on how well you are able to train on your data set. So when you look at the plot I was showing before, you see that the training cost is quite high. And basically you have this kind of arm bow that after just very few epochs, you have this kind of straight line. So this is telling you that you are just doing a very, very bad training. And you need to figure out why, basically. And you are going to do that in the tutorial. And this has to do with like the learning rate. It has to do with basically the activation function that you are using, right? So I just ran the code for you to have an idea of what is happening. And then you need to read through the code to understand which kind of architecture we are using. So I just told you that we are using a feed-forward neural network, but I didn't tell you exactly how many hidden layers are there. So you need to like read the code and understand what the architecture of the neural network is. Okay, and then here you will need to add a hidden layer, okay, with 4 hidden neurons, and to see how the accuracy changes. And to see, basically, you're gonna see that these boundaries, instead of being lines, they are going to like bend somehow towards representing accuracy in which branch your data points belong, right? Yeah, and then, okay, I didn't talk much about this. So here, okay, you are just importing NumPy, Matplotlib, TensorFlow. This is just for plotting purposes. Here, this is where you see create and plot the data set. Okay, this is where you generate the data set. This is the number of points you have per branch, right? And this is the number of branches. So I just do a simple example. If I take 4 branches here, you see now that I have like 1, 2, 3, 4 different colors and 4 different branches, you see. So for the number of points here are 50. And you see that the branches are not uniform, so there is some noise that I call mark noise. And here you generate the data, you plot the figure, okay. This is where you define your network, basically. All right, so this is some the input data and the label that you define using TensorFlow. This is how you define your first layer. So basically, W1 is like the weights for the first layer, and these are the biases. So this Z1 is like like your input data times the weights of the hidden layer plus the bias, like one was explained today. And then you basically use the sigmoid activation function on this to have like the result of, of what your neural network gives. So you will need to add an additional layer here, somewhere here.
Why is W a random variable? This is for the stacking. W1 is the random normal.
Yeah, let's say that's, you can do whatever you want, that because you are supposed to learn W. That's the idea.
That's right. So
yeah.
It's just for stacking.
Yeah. Okay, and then you define the one-hot encoding, how you encode which branch you belong to. The cross entropy, which is the cost function you use here. And you might change the cost function and use the mean square error, like Ron explained today. All right. This is the learning rate, which is an hyperparameter you need to play with. And so this enters in how you do your gradient descent, it's the parameter in front of the gradient of the cost function respect to the parameters of the network, right? And it's quite important on how it tells you how slow or fast you basically do the gradient descent. This is the number of times you run gradient descent, which is called the number of epochs. Okay? And this is where you do the training. You start the session with TensorFlow. And okay, this is just to update the nice plots that you see. It's not very important. And this is where you basically do the training. For each epoch, you basically run gradient descent. You give in your training data for, the training set and then the corresponding labels, right? And then here is just to update the plots. And yeah, and you print basically the cost of how the cost function goes with the number of epochs and how basically the accuracy of your training goes with the number of epochs. So that's it. It's not a very long Python code, right? So coming back to what you're supposed to do. So another thing you have to do is to change the activation function from a sigmoid to the rectifying linear unit and to see how the training changes when you change the activation function. And then you will have to change the cost function with the mean square error instead of the cross entropy, because now the code is the cross entropy, right? And you will see the effects of the learning rate when you increase and decrease it, and you examine these effects on different kinds of cost function here, like cross entropy and the mean square error, right? And yeah, this is where you have to figure out why this K, this one-hot encoding is useful on these K-dimensional data. Also here, I was having in mind to do some group work, but I don't know how feasible it's going to be since there are so many people. So I wanted to divide each hall into 6 groups, because in this part of the tutorial, we want to basically understand really how the parameters of the network changes the accuracy, right? So the idea here is that you want to plot basically some parameter K, you want to plot the accuracy in training your neural network with respect to some parameter K, okay? The K here is either the number of neurons in the hidden layer, so how the representation of your neural network is able to capture really the information that is inside your data. So you plot the accuracy with respect to the number of hidden layer. Here you plot the accuracy with respect to the magnitude of the noise of the data. And here you want to plot the accuracy with respect to the number of labels. If you increase the number of branches, you could imagine that the accuracy will probably decrease, because it's going to be difficult to be able to classify, to draw boundaries in between the different branches, right? So so I don't know how feasible it's going to be. If we could divide ourselves into, okay, maybe after 30 minutes, divide ourselves into 6 groups, and then maybe one group on one row, or I don't know how you're going to divide it, is going to just deal with plotting the accuracy of the neural network with respect to the number of neurons. Another group will deal with plotting the accuracy with respect to the noise, and the other one will plot the accuracy with respect to the number of labels, right? And in this case, we're just going to deal with a fit for a neural network with one hidden layer. Right? Not so in the previous exercise you have to add a second layer, but here you just use one layer and see and just play around to understand really. I mean how the fit for neural network is working. So
this will be for the afternoon session,
for the afternoon. Okay, probably because let me see. What time are we stopping?
No, I'm just asking.
Yeah, they will continue in the afternoon session.
Right.
Yeah, okay. Sure. And then there is at what time am I stopping still?
Sorry.
I think I'm speaking too much, man. I'm really. Yeah, so you can just.
I did set up the groups.
Yeah, you can start on it. I just want to mention something very fast, really very fast. This is in case you finish, if you finish with what I just presented and maybe in the night you want to play around with something, I add a bonus tutorial for those who will be interested. You use the code that we had yesterday to generate configuration of the Ising model at different temperatures, and you basically want to classify them using the fit for a neural network. So you just go through the tutorial and check, and you generate some plots from what Ron and Roger did before. So if you can do it later on, you have to finish with the first tutorial before looking at it. So you can get started. You can start.